5-2, proving triangles are congruent using side, 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 and side angle side. So at the first section, we said that triangles were congruent if all 6 pairs of corresponding parts were congruent. So that was the 3 pairs of corresponding angles and the 3 pairs of corresponding sides. Now we're going to move into theorems and postulates that allow us to prove triangles are congruent without needing all 6 pairs of corresponding parts. The first of these is side, side, side. If we have 3 sides of one triangle congruent to 3 sides of a second triangle, the 2 triangles are congruent. And we can see that side, side, side. Okay, so looking at our example here, keep in mind that anytime we have a common side, which JK is a common side, if I would draw this triangle as 2 separates, you can say that JK is congruent to itself. JL is marked with HJ and HK with KL. So we do have, and we can write these over here, HJ congruent to JL, HK congruent to KL, and JK congruent to itself. Side, side, side. That's probably the easiest triangle congruence one to do, is the 3 sides. Now we go into side, angle, side, and we have this thing called an included angle. An included angle is the angle created by 2 sides. So looking at this diagram up here, AB is one side, BC is the other, and the included angle then is angle B or angle CBA, however you want to identify it. It's that angle created from the 2 sides. So when we talk about side, angle, side, it's 2 sides and the included angle, the angle that's in between or created by those 2 sides. So looking at our diagram, first thing we're going to do here in 9 through 14 is name the included angle between the 2 sides. So the first one says AB and BD. So the included angle would be ABD. Since B has more than one angle from it, it means B is the vertex for more than one angle, you have to name it with 3 letters. In number 10, we have CD and BC. So it's going to be angle BCD. In number 11, you have AC and CB. So that's ACB. It's actually the same angle as the one before. BA, start changing colors here. BA, I'm going to write in purple, and AD is angle BAD. DC and BD, angle BDC. And BD and BC is angle DBC. Okay, so the first thing we need to do is just make sure that we know what an included angle is, so that when you try to find your side angle side, you know what you're looking for. Okay, so the next example is using side angle side. So the first thing we want to do is mark our overlap or split this in to 2 separate triangles. marking what's given. And DB is congruent to itself. So I can mark that as a common side. So I have AB congruent to CB. I have angle, I'm going to say angle B congruent to angle B. They're both right angles. And you have DB congruent to DB. So you have side, angle, side. In the next one, if I split that into two separates, G, F, E, G, H, E, you have GH and GF are congruent, GE and GE are congruent, and you have angle E and angle E. So what's going on here is, yes, you have two sides and an angle, but the included angle is down here where I have marked in green. Is that marked congruent? No. So this would be not enough info. Angle E is not the included angle. Okay, and there's some practice there for you to try. This is the end of 5-2 day 1.